Yeah, question 11. We're going to start with 11. Is on geometric progression. The third and the sixth term of a geometric progression are 1 over 4 and 1 over 32 respectively. Find the first term and the common ratio to the seventh term. Now, for a GP, it has a general formula of T sub n equal A dot R raised to the power n minus 1, where A is the first term, R is the common ratio, n is the number of terms, and T sub n is the corresponding value for n. Now, if you watch my video on series and sequence, I said something, there is a relationship between n and T sub n, that for every n, there is a corresponding T sub n, there is a corresponding value for T sub n. Now, in this problem, we're told that the third term, meaning that when n is 3, T sub 3 is 1 over 4. When n is 6, T sub 6 is 1 over 32. So therefore, we want to find the first term and the common ratio of the sequence. So what we need to do, we're going to plug in all of these values into this formula. So T sub 3 is 1 over 4, so I'm going to do 1 over 4 equal A raised to the power R. This is when n is 3, I'm going to do 3 minus 1. So 1 over 4 equal A raised to the power R, A dot R raised to the power 2. So this is equation 1. Then I'm going to do the same thing. For T sub 6 is 1 over 32, so I'm going to plug in 1 over 32 here. 1 over 32 equal A R raised to the power n minus 1. N is here 6. I'm going to write 6 minus 1. So 1 over 32 equal A raised to the power AR raised to the power 5. This is equation 2. Now I have two equations and I want to find the value of the first term and the common ratio for the geometric progression. So therefore I'm going to do this. So I have A dot R squared equals 1 over 4, and then AR raised to the power 5 equal 1 over 32. This is equation 1, this is equation 2. Now the next thing I'm going to do, I can express R in terms of A in equation 1. If I do that, I think that's, now if I do that, this is equation 1, AR2 equals 1 over 4. So if I cross multiply, let's say I cross multiply, I'll have 4AR squared equals 1. Now if I divide both sides by 4A over 4A, this cancels this, so R squared is 1 over 4A. Now this is equation 3. Now I can substitute equation 3 into equation 2. So R squared equals 1 over 4A. This is equation 3. Now from equation 3, we are going to substitute the value of R squared into equation 2. But this is what I want you to do. In this place, you have to break this down by doing A raised to the power R3 dot R2 equal 1 over 32. The reason why you need to do that, because from the law of indices, R3 times R2 is more like they have the same base, take one of the base and sum their power, it will give you 5. So we have to break it down so that you can substitute the value of x into this expression. So if we do that, now I have A R raised to the power 3 dot R squared is already this. I'm going to plug 1 over 4A into that expression. Then I'll have equal 1 over 32. So A will cancel out A. If I cross multiply, this is more like saying R raised to the power 3 over 4 equal 1 over 32. If I cross multiply, this is more like saying r raised to the power 3 equals 4 over 32. Now, if you reduce this to the lowest term, you're going to get r raised to the power 3 equals 1 over 8. Now, you go and watch my video on exponential equation. Now, when you get to this point, in my video, what I said about exponential equation, this is r raised to the power 3 equals 1 over 8. How do we solve this problem? Now, I want to get rid of the power. In my video in exponential equation, I said in order to get rid of the power, it means I'm going to multiply both exponents by the inverse of 3. This is 3. If I multiply by the inverse of 3, I'll get 1 over 3, and then the power goes up. If I do that, I'm going to get r raised to the power 3 multiplied by 1 over 3 equal 1 over 8 all to the power of 1 over 3. Now, if I do that, my r will be, now I have a fractional base and a fractional power, the fractional exponent, whose numerator is a 1. From the law, I said that the denominator will become the root of the base, so I have the third root of 1 over 8. Now, r will be the third root of 1 is 1, the third root of 8, you can punch a calculator, will give you 2. So my common ratio is 1/2, so it's 1/2. So now, the next thing I want to do, I want to find the first term, which is a. So I'm going to go back to my equation, which is actually this. I'll go back to my equation. I want to find the value of r, so I can use equation 1. ar squared equals 1 over 4. So r is 1/2, so I'm going to plug in 1/2 here. So 8 into bracket 1/2 all squared equals 1 over 4. So this will give me a bracket 1/4 equal 1 over 4. So this is like saying I have a over 4 equal 1 over 4. So these cancel this. So a will be equals to 1. So a is already 1. I've gotten my first term and the common ratio. The next thing, the question says find the seventh term of the sequence. Now, in order to get the seventh term of the sequence, I'll go back to my general formula, which is t sub n equal a to the power of ar raised to the power n minus 1. Now, the seventh term means when n is 7, I want to get a corresponding value for t sub n, which is t sub 7. I want to find t sub 7. So all I need to do is to plug in all of, I already know what a is. My a is 1. My common ratio is 1/2. So therefore, if I plug in all of this into this, I'm going to get t sub 7, which a is 1. I'm going to plug in 1 dot, which is times. R is 1/2. All to the power of n is 7 minus 1. So t sub 7 will be, this is 1/2 to the power of 6, which will give me 1 over 2 to the power of 6 is 1 over 64. So that is the seventh term for the sequence. Now 11b. 11b say given that 2 and 3 are the roots of the equation, which means x equals 2 and x equals negative 3. These are the roots of the equation. Now this equation, ax squared plus bx plus c equals 0. This is the general form of every quadratic function. Now the question says we should find the values of a, b, c. It is very simple. All I need to do, this is x equal to, or x equals minus 3. I'll take this in, so I have x minus 2. I'll do the same thing. This negative crosses the equality sign, it becomes plus 3 equals 0. So I'm going to open up the brackets, this multiplied by everything here, minus 2 multiplied by everything in the other bracket. So I have x into bracket x plus 3 minus 2 into bracket x plus 3 equals 0. So x times x is x squared. X times plus 3 will give me plus 3x. Minus 2 times x will give me minus 2x. Minus 2 times 3 will give me minus 6 equals 0. So in this case, I'm going to do x squared plus 3x minus 2x, because they are like terms. I'm going to get plus x minus 6 equals 0. Therefore, if I want to compare this equation with this, I'm going to get the values of x here. So I'm going to compare coefficient A, comparing this and this. A is 1 here. B, the coefficient of B, this is B. The coefficient here is also 1. Then C is negative 6. So that's it. Very simple. So now that's the values of A,